I want to show you a step-by-step process because there are a lot of problems and you have to know the workarounds or why are there certain pieces of code in the final solution. So we've got our Git repo set up, and now what you want to do is run lerna init with flag independent. That flag basically means that we want to have our packages versioned separately. What does it mean is that each package can have individual version, so you don't have to release them all at once. If we won't provide this flag, lerna will always keep the version synced through all of the packages. For example, Babel does that. So when you import Babel core and I think Babel runtime, they will always have the same version when the new version is published. So this is what we get from lerna init. It will just create a lerna JSON and the root package JSON and the packages folder. The packages folder is the place where we will put our stuff. So we want to use yarn with lerna, and that's possible by updating your lerna JSON, and you just have to specify the npm client as yarn, and then we just need to flag that we want to use the workspaces feature from yarn. We also want to update the package JSON, which is in root, and tell where it can find our child packages. So we update this workspaces section, and we tell it that the packages, yarn packages, will be located inside the packages folder. Then we want to create our base mobile, web, and the server. How can we do that? We'll just for React Native. Let's start with mobile. For mobile, there is a React Native init template for TypeScript because we will be using we are going to use TypeScript. So you just run this, and everything will be done automatically for you. What you will get is some folder structure, and we just need to do some changes there. We generated our mobile app with a name mobile app, and we just want to rename the package to mobile. And also we will change the name in the package JSON to this format at monorepo-example/mobile, because this format is used in monorepos. It's a common format which is used there. So you use a prefix and then slash and the name of your child package. Now we want to also init the web project. So again, create React app gives you a template for initializing TypeScript. So we can just run it in our packages folder. And again, we will just do some changes in the packages and give it a correct name according to our naming convention. Now we will do the same for the server with basic yarn init. And again, the same naming convention, monorepo-example/server. This should be the whole setup I wanted to show you. I'm skipping some common stuff like initializing Koa, Apollo GraphQL server, and stuff like that to save some time. Now, if you will do all of this, just check that all of the names are correct, and we want to have each child package to start at the same version, and all of them should be private. If you won't specify the private flag to true, lerna will treat it as a public package, and during the publishing process, it will ask you to publish it to npm, which we don't want to do in our client projects mostly. Now, when we have all of the main packages created, we will create just the shared folders I mentioned. Core for sharing the core stuff like util functions and constants and stuff like that. Theme for sharing the styling related stuff, and types for GraphQL types, which will be shared between the clients. So I mentioned this in the beginning, why we are creating these just as folders and not packages. It's always better to start with folders if you don't know yet if these folders will have dependencies or not. So how to add it? It's pretty simple. Just make these directories, and our final folder structure will look like this. So we've got our local packages, which are not versioned, and then we have our child packages, which are versioned and which are our standalone applications. So let's check the size of the root package, because during this process we were not utilizing the Yarn workspace's features, because we were doing everything with Yarn init, or we were using the scripts from the Create React App and React Native. So the size is around 650 megabytes. And we should also check that web and mobile are working, and they are. Now, let's unleash the power of Yarn. And what we want to do is, first of all, run lerna clean from the root. This is one of the commands which are pretty useful. And what it will do, it will remove the node modules from each child package. And also you can hook some custom cleaning procedures to that if you want. So one of the useful commands from Lerna, and you don't have to implement it yourself. And then we will run yarn install or Lerna bootstrap. If you will run Lerna bootstrap as per Lerna documentation, it will just run the yarn install under the hood, so it doesn't really matter. What that will do, we'll create a child yarn log file in your root. And now when we will check the size of your root folder, it will be 560 megabytes. So just on the basic scaffolding, we saved up like 90 megabytes of disk space. And you can imagine what can it save when we will have ton of dependencies and, for example, different packages. So if you want to check what the hosting is doing in your project, you can run yarn y command. Let's say we want to check what's happening to React package, because we know that mobile and the web are using that. So when you will run yarn y, it will just tell you from where it was hosted and how much disk space we have saved with that. And this command is very useful when it comes to debugging. So let's run our check after we run the yarn install. If we run the web, everything is fine. If we will run the mobile app, it will fail because it could not read the scripts, something from the React Native CLI. Now that's the first problem. So what's happening here? The thing is that for some reason, the React Native can't find this package. So let's run yarn y and see what happened. What happened is that Yarn Workspaces hosted this package from the mobile child package to the root, and Metro Bundler can't find this when it's running the scaffolding or the initialization of the React Native app. So that's a problem. If we will check a mobile folder for node modules, that's at the top, we will see that there is no node modules package for the React Native CLI, and indeed it was moved to the root folder and symlinked from there. But the sad thing is that before the React Native app is initialized, it can't follow symlinks. There is a workaround, or not a workaround, but official way supported by Yarn how to bypass this, and that's the no hoist section in your config. What no hoist does, as you can tell, is that it will forbid hoisting of the React Native package to your root folder. And basically it supports the glob patterns, so you can specify some wildcards and stuff like that. So we will just add it to the no-hoist in root and check if everything is okay. Great, both of the apps are running. And now here comes the fun stuff we encountered in the record set, and you will encounter it too if you we'll do a monorepo. So before before I will tell you about the fun stuff, I did some helper scripts and created Android build configs and everything, so we can run it. And the important thing is that I moved TypeScript package to root dev dependencies, because each of our child packages will share the same TypeScript configuration or the same TypeScript dependency. So what we want to do first is to configure absolute paths, because we don't like relative paths. What we will need to do is to have them working outside of root folder, because, for example, we will want to include our core package, core folder in web package. We want to support aliases and so on and so on. You will see. So this is our root, this is our structure, and let's just add some constants folder to the core shared folder. And it looks like this. So this is what we will have in core folder, and on the right side there is a definition of constant we will have in theme. The only difference is that the theme uses enum from TypeScript. When we will try to import this, let's say in your web package, the TypeScript resolution will fail because it can't resolve the path. So how to solve it is you will add tsconfig to your root, and then you will also add tsconfig to your child packages and configure it. So this is, for example, configuration in tsconfig for the web. As you can see at the top, I'm extending the root definition, the root tsconfig, which holds some common shared stuff. And what's more important is that we want to specify the aliases for our paths to TypeScript. So we will add the paths section to our compiler options where we specify them. Okay, moving on. Right now, if I will switch to the web package, I can see that the paths were suddenly resolved correctly, and I have the autocomplete and everything I need. Now, what happens is when we try to run the web app. So it's running React script start, and then there is this weird message. The following changes are being made to your tsconfig JSON file. Compiler option paths must not be set. So what that's saying is that Create React App does not support the aliases for paths in TypeScript, and the compilation will fail, and it will even remove the paths from your tsconfig. So that sucks. Can we do something about it? Yes, there is a workaround. If you will create different tsconfig JSON file, and if you will name it differently than tsconfig JSON, let's say you will include the paths section in the name, then you can put your paths there and extend this file in your web tsconfig JSON. What will happen? This is how the paths config looks like. We just move paths there, and we will just extend that file in the tsconfig reference in the mobile in the web app. What will happen is that we will get the same message during the compilation, but it will just work. I mean, the TypeScript will work in the end. But again, we get some error. The module was not found. Okay, so what can be the problem? We've got the TypeScript set up correctly, and yes, it's Webpack, because the sources are compiled with Webpack for the Create React app. So I want to configure our path aliases for Webpack. That's a problem because Create React app does not allow that. As many of you know, there is this tool called Krakow, which allows you to modify the CRA configuration without ejecting from that. So we will just create Krakow config, and to do our aliases there. It should be pretty easy. It's even in the Krakow documentation, no problem, right? So we will install Krakow, and we will just switch React scripts for the Krakow in our build scripts. Let's configure it and test. So when we start it, we still get the module not found. So what I want to do is alias paths outside of the root folder in the create React app. Can you do it for me, please, Krakow, and create React app? And the answer is no, because there is one thing in create React app which is called module scope plugin, which is located in the webpack config in the create React app, and that plugin basically forbid any imports going from outside of the root folder. So we are not able to import anything from our local shared folders. But we can develop a custom Krakow plugin to bypass this. So this is the code, and the important stuff is on the line 9. When we will detect that there is this module scope plugin, we will just tell it, hey, use every path we will send you in config and allow resolution from each of these paths to happen. And then we will also, on the line 13, we will also allow to use our custom aliases. Moving on, this is how to use it. So this is what you specify in your Krakow config. We will just send it our outside paths, which are our local packages, and then we will also define our absolute paths aliases there. This is our web app. I'm kind of switching quickly because you will get the code later, and there is a lot of stuff ahead. So we want to use the constants from core and theme, and we did the Krakow configuration. So let's run it, and it should work, right? When we run it, then the constants from the core are working, but the constants from the theme are not. And the problem there is that it says that currently there are no loaders configured to process this file, and the error is on the enum keyword. So why is that happening? Well, the answer is in the webpack config of create React app. If you will check the code, you can try to spot the issue, but I will do it for you. It's this line. Again, create React app uses Babel to transpile the code, and it's configured to transpile only the files which are in the app source path, and this source path can't be outside. And the problem is not really with the enum keyword, and the thing that it's from TypeScript. If you will write something like this and use that in your shared folder, I mean the import wildcard, it will fail also because Babel won't transpile it. So what to do about it? To be honest, at this point, I wanted to give up, but yeah, you can use Parcel to bypass this, because you would not have any of these issues if you would use Parcel. But seriously, there is a way how you can bypass it, and you need to instruct the Webpack loader from C create React app to also process the files outside of the root. So we will just add the plugin for the Krakow, and you will just specify which paths should be also transpiled, which is our local shared folders. If we will run it, then yeah, it's working. So yes, we can move on to React Native and absolute paths there. So we've got similar setup. We just want to display some stuff from core and from theme. We will run it, and hopefully it should work. Of course, it won't work. So what can we do about it? Yeah, React Native is using Metro and not Webpack for compilation of your files. And the thing is that Metro by default does not see folders outside of root, so similar problem as for the create React app. What we can do about it is to modify Metro config, and we can specify watch folders, which is on line 3, and we can tell it that it should also process the files found in these locations. Also, there is this piece of code called resolvers, and I had one problem with that. Many times when you Google this, it will include only the TS and TSX extension, and if you won't add the JS and JSX, the Metro won't pick up the JS folders, which you can find out only, for example, if you are using some dependencies which are using the JS files, and it will just fail miserably during runtime. We added the local shared folders for Metro. When we will run it, we will see in the output that Metro is really looking for JavaScript files in both our root and also in the shared folders. But then again, there is an error message, unable to resolve module. Yes, we already know we need to add the Babel aliases because Metro is also using the Babel. And the problem is really that even if we have the TypeScript paths correctly configured, what TypeScript does is that it will just compile it as it is, and it won't expand the path, the real path, so it will just keep the alias. And we need Babel module resolver for that, for native, and we need to specify it in our Babel config.js. So we will add the plugin, and you just need to configure the root, which is on line 14 for our project, and then you specify the aliases for our absolute imports of shared folders. That's it. When we run it, the output is correctly displayed. I want to emphasize that when you are doing some changes in React Native to configs, you always have to clean your cache, because there is haste module map cache, then Metro bundler cache, and React Native packager cache, and you can get really unexpected results if you change configs and don't clean them. So always do that. We successfully configured absolute paths. What we did was for create React app, we had to bend the Webpack and also the Babel via Crackle. And for the React Native, we had to include the local packages to resolution for Metro and also bend the Babel. Now let's get fancy. Let's share a hook from our core folder. So what we will do is in our shared folder, we will create a hooks folder and then some basic hook. The hook will just change your callback reference after some delay. It's pretty basic stuff and it doesn't really matter. What matters is that we are importing React on line 1, and we are doing that from a shared folder, and that folder is not a package, so it does not have package.json. So the question is, from where will it get the React? So let's see how it will go for the create React app, for the web app. We will try to import our custom created hook, and we will try to use it. So what it should do is just to change the message after 2 seconds. So let's run the check, and this is the result. So we got this error message. You probably seen it at least once if you are developing, if you are working with hooks. And what it's trying to say is that we've got probably multiple references of React in the same project. So we will run our favorite command yarn y to see what's going on. And as you can see, yarn found 2 references to React. One is in our mobile package and the second one is in our web package. And what it does, these references are different. And what the Yarn Workspaces does is move one of them to root folder. So essentially, when we go back, if we import React from our shared folder, it will get it from the root of the monorepo. And we don't really know what kind of version we'll get there, because how Yarn hoisting works is that it's just hoist the dependency with the most number of occurrences. So if you have multiple versions in your child packages of React, you don't really know which one get hoisted, and it can create issues like this later. So again, how can we solve it is add React and all of the similar packages like React DOM and React scripts to no hoist in your root. Now what will happen is that when we will clean the project and install the dependencies again, and we will go to our shared folder, it will no longer resolve React because it was removed from the root. But this is okay, because we know that the shared folder is always used either from our mobile app or from our web app, and these two have to React specified in their dependency, so we can just ignore this TypeScript error. If we will run the check for the web app, you would see that the hook is working and everything is fine. So now here comes the question, should we make the core a standalone package, because we already added some dependency, and it might be probably good to add standalone package JSON there. Well, if we will make it as core, you will lose hot reloading because you would import it as node module to your other package. So you would have to configure that manually. Also, there will be additional overhead with versioning, which I mentioned in the beginning. And there will be similar issues as we were facing with the imports, just a little bit different, but again, it's doable. And our monorepo is so small, it's not worth to do it. So we will just live with this workaround with the TypeScript ignore. Okay, now we just want to use that hook also from our React Native. So let's start it. It should work, right? It always works. What will happen is that we will get some very weird error that we are not able to resolve module Babel runtime something. So what's happening is that our React Native app is importing the file from the shared folder, but it does not follow symlinks from the files which are referenced outside of the root. We have to explicitly make it to do so. How you can do it is that, again, you would modify the metro config, and we will add this extra node modules section where you can define a proxy. What this does is that when Metro will encounter some dependency, it will always redirect the resolution to the node modules in our mobile package. And that's it, basically. So if it will process the shared folder and see React reference, it will make that shared folder to direct that reference to our mobile node modules. We just have to add these extra node modules to Metro Resolver. When we will run it and check it, it's working, and the hook will be correctly compiled. So there are, I said in the beginning that I will show you how to also do GraphQL and absolute paths for Node and this stuff, but really we are running out of time, and it's, again, as complicated as this was, so it would be a presentation for 2 hours, which you don't want. So to recap, what we've created is a monorepo example with packages, standalone packages, which are applications, and these are mobile, server, and web. And we also were able to create some shared folders, which are shared between these packages, so you can extract your core logic to a shared folder, and you can use it from both mobile and your web application, and you don't have to have duplicities and so on. We are also using Yarn workspaces with its hosting features to save up disk space, and we are using TypeScript and absolute paths. So that's it. There are some more things to consider when you are doing this. For example, why not to pull up all dependencies to root? Well, it would mean that you are basically stripping dependencies from your child package, and if you will just if you just want to build that package outside of the monorepo, for example, on your CI for some reason, or if you will publish it somewhere else or build it from somewhere else, it will fail. Hosting is not predictable, so you can't really lean on that. Yarn will just pick a dependency to the root which is referenced the most time. That's how it's currently working, but it can change. Then you have to think about things like your env variables. For example, when you have mobile and web in the same monorepo, you can't really have one env file in your root, because Create React App has access to the node process, so you would be able to access the env variables from process.env, but the mobile does not have this. There is no node process for the React Native apps, so that's just a thing to keep in mind. And also be sure that you have installed all your peer dependencies in correct packages, because if you don't, the package will use something which is hosted, and it doesn't have to be the dependency with the version you want to use.